Welcome to Module 10, Modules, Packages, and Imports. In this module, we'll explore Go's module system, package management, and import mechanisms. We'll cover creating and using modules, understanding import paths, and managing dependencies in Go projects. Question 1. What is a Go module? Answer. A Go module is a collection of related Go packages that are versioned together as a single unit. It's defined by a go.mod file at the root of the module's directory tree. Modules provide dependency management and versioning for Go projects, replacing the older GOPATH-based approach. Question 2. How do you initialize a new module in Go? Answer. To initialize a new module in Go, you use the go mod init command followed by the module path. For example, go mod init github.com/username/project. This creates a go.mod file in the current directory, marking it as the root of a module. Question 3. What is the purpose of the go.mod file? Answer. The go.mod file defines the module's path, the version of Go it requires, and its dependencies. It serves as the central configuration for a module, declaring the module's identity and managing its dependencies. The go.mod file is used by the Go toolchain to ensure reproducible builds and manage versioning. Question 4. How do you add a dependency to a Go module? Answer. To add a dependency to a Go module, you can use the go get command followed by the module path. For example, go get github.com/some/module. Alternatively, you can manually add the required directive in the go.mod file and then run go mod tidy to download the dependency and update go.mod and go.sum files. Question 5. What is the difference between direct and indirect dependencies in go.mod? Answer. Direct dependencies are those explicitly required by the module and listed in the go.mod file. Indirect dependencies are dependencies of your dependencies that are not directly used by your module. Indirect dependencies are marked with a indirect comment in the go.mod file. Question 6. What is the purpose of the go.sum file? Answer. The go.sum file contains the expected cryptographic hashes of the content of specific module versions. It's used to validate the integrity of each package that is downloaded. This ensures that the dependencies you're using are the ones you expect and haven't been tampered with. Question 7. How do you update dependencies in a Go module? Answer. To update dependencies in a Go module, you can use the go get u command to update to the latest minor or patch version, or go get module path at version to update to a specific version. After updating, run go mod tidy to remove any no longer needed dependencies and add any new dependencies. Question 8. What is semantic versioning and how does it relate to Go modules? Answer. Semantic versioning is a versioning scheme in the format major, minor, patch. Go modules use semantic versioning for dependency management. The Go toolchain uses these version numbers to determine compatibility. Different major versions are considered incompatible, while minor and patch versions should be backwards compatible. Question 9. What is the difference between a package and a module in Go? Answer. A package is a collection of Go source files in the same directory that are compiled together. A module is a collection of related Go packages that are versioned together as a single unit. A module can contain one or more packages and is defined by a go.mod file at its root. Question 10. How do you create a new package in Go? Answer. To create a new package in Go, you create a new directory and place Go source files in it. Each file should start with package name. The package name is usually the same as the directory name, but it doesn't have to be. To use this package in other parts of your module, you would import it using the module path plus the package directory. Question 11. What is the purpose of the init function in Go packages? Answer. The init function in Go packages is used for package initialization. It's called automatically before the main function starts executing. Each file can have multiple init functions, and they're executed in the order they appear in the file. Init functions are often used to set up initial states, register types, or perform one-time computations. Question 12. How do you handle circular dependencies between packages in Go? Answer. Go does not allow circular dependencies between packages. To resolve this, you need to refactor your code. Common solutions include 1. Creating a new package that both packages can import. 2. Merging the two packages. 3. Using interfaces to break the dependency cycle. 4. Restructuring your code to eliminate the circular dependency. Question 13. What is the difference between import and regular import in Go? Answer. Regular import, package, requires you to use the package name to access its exported identifiers. Import package imports the package into the current namespace, allowing you to use its exported identifiers without the package name prefix. However, import is generally discouraged as it can lead to naming conflicts and reduce code clarity. Question 14. What is a blank import in Go and when is it used? Answer. A blank import in Go is written as import_package. It executes the package's init function without making its exported identifiers available. It's commonly used for side effects, such as registering database drivers or image formats, where you need the package's init function to run but don't need to use the package directly. Question 15. How do you use internal packages in Go? Answer. Internal packages in Go are created by placing code in a directory named internal. These packages can only be imported by code in the directory tree rooted at the parent of the internal directory. This mechanism allows you to create packages that are only accessible within your module or a specific part of your module, providing a form of encapsulation. Question 16. What is the vendor directory in Go and when should it be used? Answer. The vendor directory in Go is a special directory that can contain dependency source code. When present, the Go toolchain will use packages from the vendor directory instead of the module cache. Vendoring can be useful for ensuring reproducible builds or when you need to make local modifications to dependencies. However, with the introduction of modules, vendoring is less commonly used. Question 17. How do you create and use a multi-module workspace in Go? Answer. To create a multi-module workspace in Go, you use the go work init and go work use commands. First, run go work init to create a Go work file. Then use go work use path to module to add modules to the workspace. This allows you to work on multiple related modules simultaneously, with the Go toolchain recognizing the local versions of these modules. Question 18. What is the purpose of the replace directive in Go.mod? Answer. The replace directive in Go.mod allows you to replace a module or a specific version of a module with another. It's useful for several scenarios. 1. Using a forked version of a dependency. 2. Using a local copy of a module for development. 3. Fixing a bug in a dependency without waiting for an official update. 4. Creating a custom import path for a module. Question 19. How do you handle different versions of the same dependency in Go? Answer. Go modules allow different packages within your module to use different versions of the same dependency. The Go toolchain will automatically use the minimum required version that satisfies all constraints. If you need to use two major versions of a module simultaneously, you can use the v2 or higher suffix in the import path for versions 2 and above. Question 20. What is the difference between GoGet and GoInstall? Answer. GoGet is used to add dependencies to the current module, updating Go.mod and downloading the source code. GoInstall is used to compile and install packages and executables. In modules mode, GoInstall can install executable packages without affecting the current module. GoGet modifies Go.mod, while GoInstall doesn't. Question 21. How do you create and publish a Go module? Answer. To create and publish a Go module, 1. Initialize the module with GoMod init. 2. Write your package code. 3. Use semantic versioning for releases. 4. Tag your releases in your version control system. 5. Push your code and tags to a public repository. Other users can then import your module using its path, like github.com/username/module. Question 22. What is the purpose of the gomod tidy command? Answer. The gomod tidy command is used to add missing modules necessary to build and test all packages in the current module, and to remove unused modules from go.mod. It ensures that the go.mod file accurately reflects the dependencies required by your code, helping to keep your module's dependency list clean and up to date. Question 23. How do you handle dependency conflicts in Go modules? Answer. Go modules handle most dependency conflicts automatically by using the minimum version that satisfies all requirements. For more complex cases, 1. Use Go Mod Graph to visualize dependencies. 2. Use Go Mod Y to understand why a module is needed. 3. Use replace directives if necessary. 4. Consider updating or changing dependencies to resolve conflicts. 5. As a last resort, fork and maintain your own version of a problematic dependency. Question 24. What is the purpose of the retract directive in Go.mod? Answer. The retract directive in Go.mod is used to indicate that certain versions of a module should not be used. It's useful when you've published a version with a severe bug or security issue. Retractions are visible to the Go command and prevent automatic upgrades to the retracted versions. This allows module authors to effectively unpublish problematic versions without removing them from the version control system. Question 25. How do you use build tags for conditional compilation in Go? Answer. Build tags in Go allow for conditional compilation. You can use them by adding a comment at the top of a file. Plus build tag 1 tag 2. Files with build tags are only included in the build if the specified tags are satisfied. You can use build tags to create platform-specific code, include or exclude tests, or create different builds for development and production environments. Welcome to Module 11, Go Tooling. This module introduces you to the rich ecosystem of Go tools. We'll cover essential commands like Go Build, Go Test, and Go Vet, as well as exploring code formatting with GOFMT, documentation with Godoc, and performance profiling tools. Question 1. What is the purpose of the Go Build command? Answer. The Go Build command compiles Go packages and dependencies, but it doesn't install the result. It's used to compile the package in the current directory or the packages specified by the import paths. If the package is main, Go Build creates an executable. For other packages, it only checks for correctness and discards the resulting object. Question 2. How do you cross-compile Go programs for different operating systems and architectures? Answer. To cross-compile Go programs, you use the GOOS and GOARCH environment variables with the Go Build command. For example, to build for Windows 64-bit from a Unix system, you would use GOOS equals Windows GORCH equals AMD 64 Go Build. This creates an executable that can run on the specified OS and architecture. Question 3. What is the difference between Go Build and Go Install? Answer. Go Build compiles packages and dependencies but doesn't install the result. Go Install compiles and installs the packages and their dependencies. For non-main packages, Go Install places the compiled package in the package directory. For main packages, it places the executable in the bin directory. Question 4. What is the purpose of the Go FMT command? Answer. The Go FMT command formats Go source code files according to the standard Go style. It uses tabs for indentation, blanks for alignment, and rewrites the source in a standard format. This tool helps maintain a consistent coding style across Go projects and is widely used in the Go community. Question 5. How does the Go Test command work? Answer. The Go Test command automates testing of Go packages. It looks for files ending in _test. Go compiles them along with the package being tested, and runs the resulting tests. Test functions should begin with test and take a single argument of type testing, T. The command reports whether the tests pass or fail. Question 6. What is the purpose of the Go Vet command? Answer. The Go Vet command examines Go source code and reports suspicious constructs that might indicate bugs. It can detect issues that aren't caught by the compiler, such as useless assignments, unreachable code, or misuse of functions like printf. While it doesn't catch all bugs, it's a useful tool for identifying potential issues in your code. Question 7. How do you use the Go Mod command for dependency management? Answer. The Go Mod command is used for module maintenance. Common subcommands include Go Mod Init to initialize a new module, Go Mod Tidy to add missing and remove unused modules, Go Mod Vendor to make vendored copies of dependencies, and Go Mod Graph to print the module requirement graph. These commands help manage dependencies in Go projects. Question 8. What is the purpose of the Go Generate command? Answer. The Go generate command scans Go files for special comments of the form Go generate command and executes those commands. It's used to automate the generation of Go code before compilation. This can include generating code from templates, updating generated code, or running other tools as part of the build process. Question 9. How does the Go run command differ from Go build? Answer. The Go run command compiles and runs a Go program in one step, without producing an executable file. It's useful for quick testing and running scripts. Go build, on the other hand, compiles the program and produces an executable but doesn't run it. Go run is more convenient for development, while Go build is used for creating distributable binaries. Question 10. What is the purpose of the go doc command? Answer. The go doc command prints documentation for a package, function, variable, or method. It extracts this documentation from Go source code comments. For example, go doc fmt, println displays the documentation for the println function in the fmt package. This tool is useful for quickly accessing documentation without leaving the command line. Question 11. How do you use the go list command? Answer. The go list command lists packages or modules. By default, it lists the import paths of the named packages. With the F flag, you can use the template language to format custom output. For example, go list F import path. Name all lists the import path and name of all packages. It's useful for scripting and gathering information about your Go environment. Question 12. What is the purpose of the Go tool pprofessor command? Answer. The Go tool pprofessor command is used for profiling Go programs. It can analyze CPU usage, memory allocations, Go routine blocking, and more. It reads profiling data generated by the runtime pprofessor package or the net HTTP pprofessor endpoint. pprofessor provides both a command line interface and a web interface for visualizing and analyzing performance data. Question 13. How do you use the go tool trace command? Answer. The go tool trace command is used to analyze execution traces of Go programs. It provides a web interface to visualize various events during program execution, including Go routine creation and blocking, system calls, and garbage collection. To use it, you first generate a trace file using the runtime trace package, then view it with go tool tracefile.out. Question 14. What is the purpose of the go clean command? Answer. The go clean command removes object files and cached files from the package source directory. It's useful for cleaning up the build artifacts and ensuring a clean state for your project. With different flags, it can remove build output files, test cache, module cache, and more. This command is often used before rebuilding to ensure a fresh start. Question 15. How do you use the go env command? Answer. The go env command prints Go environment information. Without arguments, it prints all environment variables. You can specify names to print specific variables, like go env-gopathgoroot. It's useful for scripts that need to know about the Go environment. You can also use go envw to set certain environment variables for future Go commands. Question 16. What is the purpose of the GOFMT tool? Answer. GOFMT is a tool that automatically formats Go source code. It's the same formatter used by the go fmt command. GOFMT can be used directly or integrated into text editors and IDEs. It enforces a standard coding style, which helps maintain consistency across Go projects and reduces debates about formatting in code reviews. Question 17. How do you use the go fix command? Answer. The go fix command updates packages to use new APIs. It applies automated fixes to Go source code to handle API changes between versions of Go. While it's not commonly used for day-to-day development, it can be helpful when upgrading to a new version of Go that includes breaking changes to the standard library. Question 18. What is the purpose of the golint tool? Answer. Golint is a linter for Go source code. It prints out style mistakes and provides suggestions for improving code quality. Unlike GOFMT, which reformats code, golint only provides advice. It checks for things like naming conventions, comment formatting, and common coding mistakes. While not part of the standard Go toolchain, it's a widely used tool in the Go community. Question 19. How do you use the Go tool cover command for code coverage? Answer. The Go tool cover command is used to analyze code coverage of Go tests. You first run tests with coverage enabled. Go test cover profile equals coverage.out. Then you can view the coverage report in the terminal with Go tool cover func equals coverage.out, or generate an HTML report with Go tool cover HTML equals coverage.out. This helps identify areas of your code that aren't being tested. Question 20. What is the purpose of the Go tool ASM command? Answer. The Go tool ASM command is the Go assembler. It's typically not used directly by developers, but as part of the Go toolchain. It assembles Go assembly language files, ending in S, into object files. This tool is useful for performance-critical code that needs to be written in assembly, or for understanding the low-level details of Go's implementation. Question 21. How do you use the Go mod vendor command? Answer. The Go mod vendor command creates a vendor directory and copies all dependencies into it. This allows you to include all dependencies in your version control system. To use vendor dependencies, use the mod equals vendor flag with commands like go build or go test. Vendoring can be useful for ensuring reproducible builds or when you need to make local modifications to dependencies. Question 22. What is the purpose of the Go tool compile command? Answer. The Go tool compile command compiles Go source files into object files. It's a lower-level tool that's part of the Go toolchain, typically used internally by commands like go build. Advanced users might use it directly for custom build processes or to analyze the compilation process. It provides various flags for controlling the compilation process and output. Question 23. How do you use the Go tool nm command? Answer. The Go tool nm command lists symbol table of object files. It's similar to the Unix nm command. This tool can be useful for debugging, understanding binary sizes, or analyzing what symbols are exported from a package. For example, Go tool nm binary file will list all symbols in the binary, including function names and global variables. Question 24. What is the purpose of the Go tool objdump command? Answer. The Go tool objdump command disassembles executable files and object files. It's useful for low-level debugging and understanding how Go code translates to machine code. You can use it to examine the assembly output of your Go programs. For example, Go tool objdump s main binary file will show the disassembled machine code for the main function. Question 25. How do you use the Go work command for multi-module workspaces? Answer. The Go work command, introduced in Go 1.18, is used to manage multi-module workspaces. You can use Go work init to create a Go work file, Go work use to add a module to the workspace, and Go work sync to sync the workspace's dependencies. This allows you to work on multiple related modules simultaneously, with the Go toolchain recognizing the local versions of these modules. Welcome to Module 12, Concurrency in Go. In this module, we'll dive into Go's powerful concurrency model. We'll explore Go routines, channels, and the select statement, discussing how Go makes it easy to write efficient concurrent programs. We'll also cover synchronization primitives and common concurrency patterns. Question 1. What is a Go routine in Go? Answer. A Go routine is a lightweight thread managed by the Go runtime. It's a function executing concurrently with other Go routines in the same address space. Go routines are much cheaper than operating system threads, allowing thousands of Go routines to run simultaneously. They're started with the Go keyword, like Go my function. Question 2. How do channels work in Go? Answer. Channels in Go are typed conduits through which you can send and receive values with the channel operator, less than. They provide a way for Go routines to communicate and synchronize their execution. Channels can be buffered or unbuffered. An unbuffered channel blocks the sender until the receiver is ready, while a buffered channel only blocks when the buffer is full. Question 3. What is the difference between buffered and unbuffered channels? Answer. Unbuffered channels have no capacity to hold values and require both sender and receiver to be ready at the same time for communication to succeed. Buffered channels have a capacity and can hold one or more values before blocking. Unbuffered channels provide strong synchronization, while buffered channels can decouple sending and receiving operations to some degree. Question 4. How does the select statement work in Go? Answer. The select statement in Go lets a Go routine wait on multiple communication operations. It blocks until one of its cases can run, then executes that case. If multiple cases are ready, it chooses one at random. The select statement is key for managing multiple channels and implementing timeouts. It can also include a default case to make it non-blocking. Question 5. What is a race condition and how can you detect it in Go? Answer. A race condition occurs when two or more Go routines access the same variable concurrently and at least one of the accesses is a write. This can lead to unpredictable behavior. Go provides a race detector tool that can be used by adding the race flag to Go test, Go run, or Go build commands. It helps identify race conditions in your code. Question 6. How do you implement a mutex in Go? Answer. Go provides sync, mutex for implementing mutual exclusion. You can use it to protect shared resources from concurrent access. A basic usage looks like this: var mu sync, mutex, mu, lock, access shared resources, mu, unlock. There's also sync, rw mutex for scenarios where you have multiple readers but only one writer. Question 7. What is the purpose of the sync, wait group? Answer. Sync, wait group is used to wait for a collection of Go routines to finish executing. It has three methods: add, to add a count of Go routines to wait for, done, to decrement the count, and wait, to block until the count reaches 0. It's particularly useful when you need to wait for multiple Go routines to complete before proceeding. Question 8. How can you implement a timeout for a Go routine in Go? Answer. You can implement a timeout for a Go routine using the select statement and the time after function. Here's a basic structure. Select, case result, equals less than ch, handle result, case less than time, after, timeout, handle timeout. This allows you to either receive a result from the Go routine or timeout after a specified duration. Question 9. What is the purpose of the sync, once type? Answer. Sync, once is used to ensure that a function is executed only once, even if called from multiple Go routines. It has one method, do, which takes a function as an argument. The first call to do, f, will invoke f, while subsequent calls will do nothing. This is useful for one-time initialization in concurrent programs. Question 10. How does the context package help in managing Go routines? Answer. The context package provides a way to carry deadlines, cancellation signals, and other request scoped values across API boundaries and between Go routines. It allows you to cancel long-running operations and propagate cancellation down the call graph. This is particularly useful in servers to ensure resources are freed when a client disconnects. Question 11. What is the difference between concurrency and parallelism? Answer. Concurrency is about structuring a program to handle multiple tasks that could be executed out of order. Parallelism is about executing multiple tasks simultaneously. Concurrency is about dealing with lots of things at once, while parallelism is about doing lots of things at once. Go's concurrency model makes it easy to write programs that can potentially be parallel, but parallelism requires multiple processors. Question 12. How can you limit the number of Go routines running concurrently? Answer. You can limit the number of Go routines running concurrently using a semaphore pattern with a buffered channel. Create a channel with a buffer size equal to the maximum number of Go routines you want to run concurrently. Before starting a Go routine, receive from this channel. When the Go routine finishes, send to the channel. This effectively limits the number of concurrent Go routines. Question 13. What is a deadlock and how can it occur in Go? Answer. A deadlock occurs when a group of Go routines are waiting for each other and none of them can proceed. This can happen in Go when using channels or mutexes incorrectly. For example, if a Go routine is waiting to receive from an unbuffered channel and no other Go routine is sending to that channel, it will deadlock. Go's runtime can detect some deadlocks and will panic with a deadlock message. Question 14. How do you implement a fan-out pattern in Go? Answer. The fan-out pattern in Go involves distributing work across multiple Go routines to process it concurrently. You can implement this by creating a number of worker Go routines that all read from the same input channel. Each Go routine processes items independently, potentially writing results to an output channel. This pattern is useful for CPU-bound tasks that can be parallelized. Question 15. What is the purpose of the sync cond type? Answer. Sync cond is a rendezvous point for Go routines waiting for or announcing the occurrence of an event. It's useful when you have Go routines that need to wait for a condition to become true. It provides methods like wait, to suspend execution until notified, signal, to wake one Go routine, and broadcast, to wake all Go routines waiting on the condition. Question 16. How can you implement a worker pool in Go? Answer. A worker pool in Go can be implemented using Go routines and channels. Create a fixed number of worker Go routines that read tasks from an input channel. Each worker processes tasks and may write results to an output channel. The main Go routine can then distribute tasks to the workers via the input channel and collect results from the output channel. This pattern helps limit resource usage and improve performance for concurrent task processing. Question 17. What is the purpose of the sync pool type? Answer. Sync pool is used to cache allocated but unused items for later reuse, relieving pressure on the garbage collector. It's particularly useful for frequently allocated and released objects like temporary buffers. Each pool has a new function for creating new items when the pool is empty. However, items in the pool may be garbage collected at any time, so it's not suitable for all caching scenarios. Question 18. How do you handle panics in Go routines? Answer. Panics in Go routines will crash the entire program if not handled. To handle panics, you can use a deferred function with recover inside each Go routine. For example, go func, defer func, if r equals recover, r equals nil, handle panic, rest of the Go routine code. This allows you to log the panic or take other appropriate actions without crashing the entire program. Question 19. What is the difference between a buffered and unbuffered channel in terms of blocking? Answer. An unbuffered channel blocks the sender until the receiver is ready to receive. A buffered channel only blocks the sender when the buffer is full, and blocks the receiver when the buffer is empty. This means that with a buffered channel, the sender can put values into the channel even if no receiver is ready, up to the buffer's capacity. This can lead to different synchronization behavior and potentially different performance characteristics. Question 20. How can you implement a timeout for receiving from a channel? Answer. You can implement a timeout for receiving from a channel using the select statement and time after function. Here's an example. Select case value equals less than ch, handle received value, case less than time, after timeout, handle timeout. This will either receive a value from the channel or timeout after the specified duration, whichever comes first. Question 21. What is the purpose of the runtime GoMax Pro CS function? Answer. Runtime GoMax Pro CS sets the maximum number of CPUs that can be executing simultaneously and returns the previous setting. By default, Go uses all available cores. Calling GoMax Pro CS with a positive number allows you to limit the number of operating system threads that can execute user-level Go code simultaneously. It's rarely necessary to call this in modern Go programs as the runtime automatically adjusts to use all available CPUs. Question 22. How do you implement a publish-subscribe pattern in Go? Answer. A publish-subscribe pattern in Go can be implemented using Go routines and channels. Create a separate Go routine for each subscriber that receives from its own channel. The publisher sends messages to all subscriber channels. You can use a slice or map to keep track of subscriber channels. To add or remove subscribers, use proper synchronization like a mutex to protect access to the subscriber list. Question 23. What is the purpose of the sync map type? Answer. Sync map is a concurrent map with amortized constant time loads, stores, and deletes. It's safe for multiple Go routines to access concurrently without additional locking or coordination. It's optimized for use in concurrent loops with keys that are stable over time, and either few steady-state stores or stores localized to one Go routine. For other scenarios, you might still need to use a regular map with a sync mutex. Question 24. How can you implement a rate limiter in Go? Answer. A simple rate limiter in Go can be implemented using time. Ticker. Create a ticker that ticks at your desired rate, then use a select statement to either perform an action when the ticker ticks, or receive from a quit channel to stop the limiter. For more complex rate limiting, you might use the golang.org/x/time/rate package, which provides a flexible and efficient rate limiter. Question 25. What is the difference between closing a channel and sending a sentinel value? Answer. Closing a channel is a built-in way to signal that no more values will be sent on the channel. Receivers can detect when a channel has been closed. Sending a sentinel value, like nil for pointers, is a manual way to signal the end of transmission. The main difference is that closing a channel affects all receivers, while a sentinel value must be processed by each receiver. Closing is generally preferred when you want to signal completion to all receivers simultaneously.